Good morning, students. Today lesson Unit 10 Types of Chemical Reactions. Unit 10 Types of Chemical Reactions. Today's topic Decomposition Reaction. Today's topic Decomposition Reaction. This is the decomposition of ammonium dichromate. This is an example of decomposition reaction. Decomposition of ammonium dichromate. First type electrolytic decomposition. Electrolytic decomposition. What is electrolytic decomposition? In some of the decomposition reactions, electrical energy is used to bring about the reaction. This is electrolytic decomposition. For example, decomposition of sodium chloride occurs on passing electric current through its aqueous solution. Aqueous solution means the salt dissolved in water. The decomposition of sodium chloride occurs on passing electric current through its aqueous solution. Sodium chloride decomposes into metallic sodium and chlorine gas. Sodium chloride decomposes into metallic sodium and chlorine gas. This process is termed as electrolysis. This is electrolytic decomposition reaction. Reactions in which compounds decompose into simpler compounds because of passing electricity are known as electrolytic decomposition. This is also known as electrolysis. Example, when electricity is passed in water, it decomposes into hydrogen and oxygen. Water, after passing electricity, is decomposes into hydrogen and oxygen. This is electrolytic solution. Cation, anion. This is cathode, anode. This is totally electrolytic decomposition reaction. Reaction in which compounds decomposes into simpler compounds because of passing electricity are known as electrolytic decomposition. This is also the example of decomposition reaction. Sodium chloride, NaCl. Sodium and chlorine is converted into chlorine and sodium or sodium and chlorine. So, one reactant involved in this reaction to form more than one product, that is sodium and chlorine. This is decomposition reaction. AB, this is a reactant to form A plus B. This is electrolytic decomposition by passing electricity. This is an important condition. Sodium chloride, aqueous solution. Aqueous solution means sodium chloride dissolved in water. After passing electricity, it is split out into sodium and chlorine. This is aqueous solution. This is solid, then gas. A compound NaCl, this is NaCl compound, is converted into elements, that is sodium and chlorine, into elements, sodium and chlorine. So, it is a type of compound to element decomposition. This is compound to element decomposition. Next type, photo-decomposition reaction. Next type, photo-decomposition reaction. What is photo decomposition? Photo means light. Light is an another form of energy. Light is an another form of energy. For example, when silver bromide AgBr, that is silver bromide AgBr, is exposed to light, it breaks down into silver metal and bromine gas. When silver bromide AgBr is exposed to light, it breaks down into silver metal and bromine gas. Breaks down into silver metal and bromine gas. As the decomposition reaction is caused by light. This reaction is caused by light. This kind of reaction is also called photolysis reaction. What is photolysis reaction? This is an important question. Light is an another form of energy. This decomposition is caused by light. So this is called photolysis reaction. This is decomposition, the same reaction, silver bromide causing sunlight to form silver and bromine. The same reaction, the color of silver bromide is yellow color. In this reaction, the yellow colored silver bromide turns into grey colored silver metal. Yellow color silver bromide turns into grey color silver metal. It is also a compound to element decomposition. Compound to element decomposition. Silver bromide, light yellow color. This is silver metal, grey color. This is a photo decomposition of silver bromide. AgBr passing light, Ag and Br2, 2Ag and Br2. This is the compound. This is element. This is element. So this is totally compound to element decomposition. Next, single displacement reaction. What is displacement reaction? More active element readily displace less active element from their aqueous solution. More active element readily displaces less active element from their aqueous solution. This is called a displacement. Single displacement. Only one displacement occur in a reaction. This is called single displacement reaction. A, B and C. B combined with C. So this is displacement. B combined with C to form BC and A is separated. So this is displacement. Single displacement reaction, it is a reaction between an element and a compound. Here A plus BC. A combined with C to form AC and B is separated. Only one displacement is occur. So this is single displacement. Okay, A combined with C, B is separated. AC and B. Okay, this is the single displacement reaction. A displaces element B from the compound BC and hence a single displacement reaction occurs. If zinc metal is placed in hydrochloric acid, the zinc metal is placed in hydrochloric acid, hydrogen gas is evolved. Here, hydrogen is displaced by zinc metal and zinc chloride is formed. Hydrogen is displaced by zinc metal and zinc chloride ZnCl2 is formed. These are also the examples of decomposition reaction. The first reaction, lead carbonate PbCO3. Pb, lead CO3 carbonate, lead carbonate. It decomposes into lead oxide and carbon dioxide. PbCO3 is decomposed into PbO plus CO2. Second reaction, lead nitrate. This is a lead nitrate, Pb, lead nitrate, NO3, PbNO3 twice. Lead nitrate, after decomposition, is converted into lead oxide, nitrogen dioxide, and oxygen. So, this is a decomposition reaction. Then, third one, decomposition of ammonium dichromate, NH4 ammonium dichromium, and combined with the oxygen to form chromate. Ammonium dichromate. NH4 twice Cr2O7 is decomposed into Cr2O3, chromium third oxide, water, that is a steam, plus nitrogen gas. Last reaction, mercury sand oxide, HgO, is decomposed into Hg and oxygen. These are also the examples of decomposition reaction. If an iron nail is placed in an aqueous solution of copper second sulfate, the iron displaces copper from its aqueous solution and the copper deposits over the iron nail. Iron nail is placed in an aqueous solution of copper second sulfate. The iron displaces copper from its aqueous solution and the copper deposits over the iron nail. The reaction Fe plus CuSO4 copper sulfate, this is solid form, aqueous solution. The copper sulfate salt dissolved in water, that is aqueous solution, to form iron sulfate. The iron combined with the SO4 to form iron sulfate, and the copper is displaced. As per the rule of displacement reaction, more reactive element readily displace less reactive element from their aqueous solution. So, iron is a more reactive element. So, more reactive element displaces a less reactive element in their aqueous solution. Here, copper sulfate is the aqueous solution. In the aqueous solution of copper sulfate, the copper is displaced by iron. So, iron is a more reactive element. The same is explained here. This is a copper sulfate solution. The color of copper sulfate is blue color. The iron nail is dipped into the copper sulfate solution. After the reaction, the blue color of copper sulfate changed into green color. What is the reason? Iron combined with the copper sulfate, the copper is separated, copper, and iron combined with the SO4, Fe combined with the SO4 to form FeSO4, that is iron sulfate. So, the color of copper sulfate changed into green color. So, before this reaction, the color of the solution is blue. After the reaction, it is changed into green color, blue color, green color. This is color of copper sulfate solution, blue. Color of iron sulfate, green. Fe plus CuSO4 gives Cu plus FeSO4. This is most easily demonstrated with halogens, the displacement reaction. Easily demonstrated with halogens. Let us consider the following two reactions, NaCl plus F2 to form 2NaF plus Cl2. Sodium chloride plus fluorine to form sodium fluoride and chlorine. The second reaction, sodium fluoride and chlorine to form sodium chloride and fluorine. The first reaction involves the displacement of chlorine from NaCl. The first reaction, NaCl plus F2 give 2NaF plus Cl2. The first reaction involves the displacement of chlorine from NaCl by fluorine. In the second reaction, that is sodium fluoride plus chlorine to form sodium chloride and fluorine. This is the second reaction. In the second reaction, chlorine displaces fluorine from sodium fluoride. In the same two reactions, out of these two, the second reaction will not occur. That is sodium fluoride and chlorine. Sodium chloride and fluoride, it will not occur because fluorine is more active than chlorine. This is the important one. Fluorine is more active than chlorine. This is a give reason question. Out of these two reactions, the second reaction will not occur. What is the reason? Fluorine is more active than chlorine. What is displacement? More active element readily displaces less active element. Here, fluorine is more active than chlorine. So, it's not possible. Displacement reaction, more active element readily displaces less active elements from their aqueous solution. Thank you, student.